Okay, hello everyone, welcome. Thank you for waiting all the way to the last session. My name is Michael Dexter, and I love BSD Unix. I love BSD Unix. So, last year at this conference, I looked at various levels of the specifically FreeBSD networking storage stack and geom and its many components, and for example looked at partitioning under a hex dump, and it looked a bit like that. It was quite enlightening for me. I hope others found it useful. Even Kirk said he found it useful. But that was way too high up the storage stack. In the context of all of this, I've been doing 3 years of FreeNAS and ZFS support. And in that time, I have talked to a lot of disks in all shapes and sizes and in various states of health. Disks are very shy. Sometimes they're completely silent for a number of reasons. And they could be perfectly healthy, but maybe hiding behind a USB interface or a storage controller that will not provide the information I want to get out of them. And so we, humanity, rely heavily on these storage devices. I hope that's a good thing in the long term, but either way, we rely on them extremely heavily. We depend on them. There are quite a few in this room, despite the fact that we're simply watching a talk. And despite all this usage, we barely know them. And part of the fundamental problem is that vendors do not talk to one another. We have a storage stack in which the actual device, the disk, might come from vendor A, and it's controlled by a controller from vendor B, and it has partitioning on top of it from vendor C, which in this case is usually a BSD Unix project. And, oh gosh. And on top of that, we optionally have a logical volume manager, and on top of that, we finally have a file system. And there's some mixing that can go on here. But with all these different sources of authority, at pretty much every level of stack, we have different pieces of software from different vendors trying to perform different roles, hopefully in a unified manner that is meaningful to administrators who need to take responsibility for every layer of that. So yes, can we talk as per Joan Rivers in the 1980s? It's a fundamental communication issue that takes place both on these simple devices and in decisions we need to make based on them. And as you probably know, the modern hard disk speaks SMART for the most part, in addition to just the CCBs that read-write and make it do all the storage things. A standards body came up with SMART, which is the self-monitoring analysis and reporting technology, and it provides various amounts of information, which vary between disks, that administrators hopefully find very accessible and very meaningful. So, conversing with a disk is fundamentally a pretty terse activity. I'm fine, thank you. It's typically hex output, and the tiny handful of utilities out there that interpret that output give typically something like this. Might be confusing to new users, the mix of parameters in which the result should be, and perhaps the raw values, and what hopefully the vendor is accurate, the utility is accurately identifying as that particular piece of information. And I'm sure anyone who's looked closely at a disk has used SMART modules. That is the de facto standard, and naturally everyone uses that, we think. People claim, but also in the BSDs. Out of NetBSD came AT-ACTL, which was imported into OpenBSD, and that's their in-base tool for collecting some of this information. and we'll get to some of its advantages and shortcomings. However, the perception is that everyone uses SMART tools, and that's a lot like everyone uses graph to format man pages. You have to wonder, is that arbitrarily, or is that because that's what the tools are and no one's really thought about how to look at them differently? So going through the SMART tools advantages, and I'll read some of these because it might be hard to read in the back there, but the availability is a key benefit. It's on nearly every operating system. There's support for SCSI and ATA devices. There's broad vendor support for various devices, and by that I mean the mapping of a given answer to what it means to the human. And those answers can vary in the time scale and the proportional scale. So a given number from a given vendor may be very different from a number from another vendor, even though it represents the same physical quality that it's attempting to represent. There is a monitoring daemon that will give you a small heads up of what's going on. And there are some built-in disk tests that can be initiated and terminated with the utility. Useful, but I think raise your hand if you have indeed sat down with your, say, laptop and run a SMART long or short test. Anyone? Anyone? We've got about half the room. Good, good. Raise your hand, do you rely on the disk in front of you? I hope everybody. So yeah, think about the fact that about half of us are performing what should be real easy basic housekeeping on our storage devices. And it's familiar because that is the tool that everyone uses, quote unquote. But SMART tools has a few disadvantages that I'll touch on. In this context, the licensing is a concern. It will never be in the base operating systems we're discussing at this conference, at HWSDCon, GTLv2 licensed, and you can retrieve it from, say, ports and packages, but maybe that's the reason that only half the people in the room raise their hands. Limited output formatting options, that I'll be talking quite a bit about. And it will not work as a library for inclusion in other utilities or your own homegrown monitoring system. It does not support NVMe devices, and there's specifically an open bug for that, and it'll happen when it happens. It does not perform acoustic management adjustments, and I'm reading off for the benefit of the non-English speakers here, so I'll try to be as clear as possible and allow you to read along with me. It does not support the security features in devices. It does not perform storage bus resets and other housekeeping. There is no SATA API eject. A few missing SCSI commands. It cannot be used for, say, manual communication with the device using just specific SCSI commands, ATA commands in and out, or SCSI commands. And the last one will be a little interesting, and it has no notion of virtual disks, and we'll get into what opportunities lie there. Now, the ATA control utilities used in OpenBSD and NetBSD have their various advantages and disadvantages. Sitting down with Rod Grimes, the FreeBSD co-founder, he found that the utility is not seeing if a device has SMART before throwing SMART command out. And there are simple little coding issues that are in it that I touch on with with coding style. It's been a long day. So the licensing does allow for its inclusion in the base operating systems. There are a few features that are not available in the SMART tools, the acoustic management. It will do basic start, stop of tests, but it generally lacks vendor information, so it will not get very deep into what a device will have as a vendor-specific parameter. Sorry. It was this last point, the disadvantages that tripped up on. So many of the same shortcomings of SMART control and such is life. So for many years, various colleagues and I have been working on various aspects of BSD, and we like to think that, well, you should understand a problem before you try to solve it, which brings me here today. And one of those projects is ManDoc. It's an alternative to Groff that formats man pages. And of course, everyone used Groff until now. Everyone uses ManDoc throughout the BSDs and the Lumos and other operating systems. And so it is possible to replace a de facto piece of software. So a key motivation can be when the disadvantages outweigh the advantages. So this all started with a tweet. I was asking my OpenBSD peeps, hey, if you can't read that in the back, OpenBSD folks, you know who you are. Can ATA control the device name, smart status, output, individual parameters like temperature? I'm well aware of smart control. Yes, we don't respond with just use smart control, I know. So the response from Damian Miller was talk to David Winnie, and this initiated a lengthy conversation over the last few months. And as I replied, that proved to be a correct statement to talk to David. And the first key point was put down your keyboard, come to events. I've been to several events, bhyve in the Bay Area, local meetups, Portland Unix, Linux Unix group in Portland, etc. Plug, and basically reach out. You can hear my frustration here in the fact that so often projects code first and then ask for feedback. So let's go through those shortcomings one by one. Number one, the licensing. It's a hard requirement to be compatible with the BSD. So in practice, that means a BSD license, an MIT license, an ISC license. These each have their subtle differences and I'd almost say political connotation of each. So I think achieving agreement there is not too difficult. Now, the number one thing I hear is an extensible output framework. For those of you SmartMon tools, it conflates a great amount of information and documentation along with the results, and people go to various lengths to perform acrobatics to parse it. Anyone in this room been through that wonderful experience of parsing smart control output? Anyone? Any representatives? So, in this day and age, we've moved away from strictly human readable output. And naturally, the hex is not appropriate for everyone, which I showed earlier. And we have modern formats, modern-ish, like YAML, XML, you name it. And I personally want shell variables, because I'm acting on that information, so I want the facts, just the facts, ma'am, as they say, and from there I will worry about what to do with it. So in Unix years, about late Unix life, Unix history, along came ZFS. And fortunately, it gets this quite right, to its credit. So zpool get all from my pool name, which happens to be my machine name, and I search for bootfs, which is where the next boot environment will, by default, boot from. There's an option to drill down zpool get bootfs on the pool, which answers simply that with the nice human-friendly headers. And then zpool get HP, no headers, parsable output, bootfs, and we get, I believe, tab-separated values for the only the information I want. And once you see that and look at the rest of the utilities on the system, you start longing for this behavior. So as for the ability to operate as a library, hypothetically, if the zpool command were aware of a smart library, we could have basic name, status, smart status, read, write, and onward. And it could be seamlessly integrated. So there are also a lot of simple usability points with SmartMon tools. NVMe support, well, look into NVMe support. Fundamental there is taking modularity into consideration from the onset and properly identifying device types and allowing one to specify a device type when interrogating it. Because if you know it's a SCSI device, you may want to say, let's only talk SCSI to this device, and to to do otherwise might either cause bad things or confusion. Security features, acoustic management, bus reset operations, lots of general housekeeping that is addressed by a few utilities, but has never ever been in one source authority. So again, the challenge is identifying a device and specifying that we only want to speak this one protocol to the one device. So those in FreeBSD land might know that, say, CAM control has the CMD option, which allows you to specify a device and throw hexadecimal commands at it. And you'll find one example floating around the internet that Mav FreeBSD posted many, many years ago, and it is repeated by everyone else. And that's the extent of everything I could find about using the CMD option in CAM control. That was a surprise. Talking at bhyve, John Baldwin said, hey, can we just dump those CCBs in and out for debugging? That would be handy. What if we could just filter them? Like I just want to see the writes to make sure they're sane. And I think that would be stunningly frustrating to implement using the CAM control CMD option. So, virtual disks, now things get interesting. I've been involved with a few hypervisors and jail-like container things, and that's what usually brings me to this stage. So, the cloud era just showed up over the years in Unix history, and there are a few different philosophies on it. One is that it's a coin-operated thing in which you deposit your coins, and services pop out, you know nothing about the magical machine that they came out of. But at the same time, that it's a commodity service and you have choice. Now, in commodity services, vendors compete with one another into the ground in a race to the bottom to keep prices down. And so if you are given that choice of provider, do you have a right to know about the environment you're operating in? If you have a virtual machine on Amazon EC2, do you have a right to know if that hosting provider is performing the most basic housekeeping that should be done on a storage system? Now, if half the people in this room are performing smart checks and tests on their devices, I feel that on some level you should have a right to know what's going on on the other side of the invisible wall that makes the magic happen. Now, I won't say a lot. Some router vendors are moving to hypervisors as just the way they operate. There's a fundamental, maybe type 1 hypervisor, and everything they do is a top hat so they can have, say, instant updates and rollback because everything is at a higher level there. Now, as you work your way up, you still want to know what is going on below you on what is a platform that you are in full control of. It's not a coin-operated cloud system, it is your fundamental architecture. So, I personally think that users have the right to know, say, what shape their storage is in when Amazon or Google provides you a storage device. I think you have a right to have some insights into what goes on there. So that raises questions. Here and now, the VirtIO and bhyve simply responds, we do not have S.M.A.R.T, thank you. But that is a completely synthetic response that could be replaced with other synthetic responses. So for example, the FreeBSD folks are very fond of ZFS, and rightfully so. And ZFS introduces whole new levels of awareness of a given storage pool, as a preferred terminology. And you get, say, probably the best redundancy strategy available with ZFS. And in that, well, if a device asks about the status of its storage pool, it magically comes from the cloud. Should that be perhaps a hybrid answer that weighs the health of the disks available, the redundancy of the pool, the fact that you still have redundancy but you've lost a device? That's something to both philosophize about, but there are also practical options, such as if that pool is comprised of a number of disks, you just simply get a long list of the results for all those devices rather than any one of them one by one. Because it is a ViRT-IO interface, it's purely software, you can synthesize whatever answer you want. Should it be the worst case answer of all the available devices? And basically aggregate all that information to something meaningful to the administrator, because you just want to know if your storage is reliable now and have the data on which you can base a decision for the future. So, working with FreeNAS developers, you may have seen a recent picture of this magnificent 90 disk array with Alan Jude standing next to it. And here and now, people still use S.M.A.R.T to query each disk, typically parse it with a language like Python, present it to a GUI. And when you start multiplying the number of seconds, hopefully not minutes, per disk, you quickly end up at best with something that will really frustrate the user. Just a long wait to say, okay, what's going on? I want to know, but perhaps not that bad, because I'm simply waiting for 90 disks to respond, which raises questions. Do we cache that information? And should a utility do that? Should the operating system be doing that? Should we log that information? Do we want that data over time? Do we want to graph that data? Because I think a few years down the road, you want to make decisions based on past data, be it vendors, be it drive models, be it enclosures. We had, I think the last talk touched on heat in JBODs. So there's a practical concern. And so in my conversations, Sean Chittenden, a FreeBSD developer, kindly pointed out, well, when you know how often a specific device is reset, and you know how often the enclosing server is reset, some very simple math can be performed to say, you know, wait a minute, why is this one device out of, say, 90 in one case, resetting, say, 7 times a minute? I think we have a problem, and that does raise further questions. Should that be handled by, say, a daemon, by a utility, by the system administrator, or yet more Python scripts? But there are simple little bits of information like that that are very, very useful. So, can that be detected with in-base tools? That's very much a question here, where we have very robust operating systems rather than tiny containers with the bare minimum utilities to function. Moving on, service hours. There are a lot of Seagate Barracudas out there. After 3 years of constant service, they start failing. That's not really super secret, and any data center has probably encountered that. We do get dumps from Backblaze and Google periodically, more so from Backblaze, on which vendors have served them well. Now, they have a business interest in simply the cost of those devices, the replacement costs, the storage planning that goes with them, and some of, again, most of these parameters are not brain surgery. Temperature, if a drive is disproportionately hot, that could indicate trouble, or if collectively you're seeing unusual heat, that can represent, say, fan failure. And that will have its own issues that cascade otherwise. So the disk is not guilty in any way, but the data is very useful in understanding what's going on. And of course, and here's where most people think, hey, smart modules, let's look at reallocated sector counts. Is this device replacing its preferred sectors with the spare sectors because, hey, something's failing in practice? Well, disks have become pretty reliable, and while that's often considered the #1 focus of smart data, in all practicality, it's these simple things like temperature, reset count, and another fun one, latency climb. If everything's working well and smart status is perfect, nothing's wrong there, but latency starts responding in a slower and slower manner. According to one system administrator, you have generally between 8 and perhaps as low as 1 or even less hours to worry about this one device, because that's a pretty reliable indicator that it is failing. Now, again, that's not smart data. However, it is equally important to any of the other concerns we've talked about. So that gets back to, do we use in-base tools? do operating systems with dtrace, rely on tools like dtrace. So, again, predictions of failure, scheduled maintenance. If a certain device has that predictable 8-hour window of opportunity while it's most likely failing, do you start a replacement early, or do you wait till all the workers go home and start then, because you are pretty sure what's going to happen? So, based on David's advice, start with documentation. I've worked out just the framework of a man page for a hypothetical S.M.A.R.T utility. And you can find that in the proceedings guide to the conference. I have a copy here if you like. But the huge breakthrough comes from things like ZFS allowing for individual parameters. No more parsing. Simply give me what I asked for. And then all the various housekeeping that is often quite simple. You drop a command on the disk and wait for a response, and there isn't much more to it. So that I envision a utility and have the interest of a BSD developer and Brad Grimes of FreeBSD, who's been quite quiet but involved in low-level disk recovery for several years, and some very kind sponsoring hosts here are also quite interested, and they've given a few talks today. Actually, multiple vendors are here today who see the need for this. And in practice, the feedback has been very, very important, so I'm intentionally leaving time to hear from you. What are the concerns you're seeing, what you would like to see, and how we move forward, because this pressing issue is not going away. Disks are getting bigger, and we rely on them pretty much completely. So, next steps. I would like to take some time now. I'd also like to discuss in the hallway track, etc., about findings, concerns, pain points, you name it, because that information has been invaluable. And to walk into bhyve with John Baldwin, Jin Lee, John Chittenden, there was a lot of wisdom available there, and we can each learn from one another. And that's been fundamental in the BSDs, because that's why we have these conferences. So I will post my contact information there, and you can reach me after this there. But here and now, simple question for, say, the Gandhi folks. If you want parsable output, are you a JSON shop? Are you a YAML shop? What would you like that to look like?
I'm more a JSON shop in that case, just because YAML is a pain in the ass and performance to parse, because it's context dependent. So anything which is not context dependent.
So if not context dependent, JSON?
JSON, UCL, whatever, I don't care. Well, actually, I would prefer having a library, and I use the library, make a Python binding on it, or whatever language binding on it to get the information.
And you're also a Python shop?
We are a Python shop, I'm not a Python guy.
Neither am I, but that's okay. So you're big enough that you have your own internal tools, your probably own framework, etc., etc. Okay?
They also good with Dexter. You can decide whatever you want to use, JSON.
So if you find that a given device is likely to fail very soon, how far does that information go in an automated sense? Is that, say, like a NetApp trigger replacement that gets express mailed to you the next day, which is often by like a drive pull? Does that information simply get to the engineers, the administrators, and they manually run and tell somebody? Or does that, in fact, automatically trigger something such as a purchase of a replacement device?
Yeah, now we do have. Now, actually, there's one thing that I'm doing with S.M.A.R.T, but then I wait until the S.M.A.R.T really reports that the hard drive is failing. And also, a proposal I made is like we collect data, because it's quite hard to predict when the hard drive will fail. And even if you have an error with the S.M.A.R.T, it can be anything else and not the disk. by itself. It can be even the firmware from it. And the best way that I think, in my opinion, is like you monitor during a period of time your storage. You get information from that the hard drive that you are using, and after that you can get several values, and you can create kind of a matrix, and then you're going to start to predict, although it's very hard, but then you can start at least to have a picture and try to predict when your hard drive is. Like an example, when you have too much ECC delay, that's is a very good point. That there is something wrong with your hard drive, but maybe it's not your hard drive. It can be your J-bar, temperature, vibration.
So false positives, how bad is that?
Yeah, I got not at Andy, but I got in my previous company. We were make a benchmark with the storage, and we have a very bad benchmark. And with the same storage, the same, of course, another set, but the same equipment, we have very good benchmark. And we didn't understand what was going on. And actually, what we found was like that set, it has some vibration. And with that vibration, the bandwidth of the hard drive drops a lot.
So the result was vibration. Was that through incorrect installation of cabinets otherwise, or?
Installation.
Interesting.
Yeah.
What metrics led you to see that? And perhaps discount the fact that it's a head failing on a drive or something that's really drive related.
Yeah, well, it was very simple things like random write, random read, so write and read. We just compare both machines, and there is a huge difference about the final result.
So overall latency on the entire array.
Yeah.
Okay, rather than one device.
Yeah.
Has anyone or everyone seen the Brendan Gregg shout at the disk array video?
Yeah.
It's a very cool video. He found that just squatting down and yelling at the disks would create very strange results. And very, very good point. And what I take away from there is the fact that something impacting all, let's just say 90 disks versus one, can be indicative very much of other factors. Yes, sir.
What about sector? So some disks have the ability to move dead sectors and mark them as don't write or read them again. So that's an indicator that the disk has a certain capability of fixing those. Do you monitor those? Of course. But how do you react to that? Is that an immediate drive failure? Is it something that should be reported, or is it something that the disk should take care of itself?
Right. So sector reallocations, as I pointed out, is one of the classic SMART things. I'm very proud to say that, and is obviously not taking environmental factors into consideration. I haven't heard hard data on just how long a drive will survive with X number or X percent of reallocated sectors, but it's generally a pretty reliable indicator that you have trouble. So for safety's sake, especially if you make or save money on that system, it's generally the red flag. And again, that's what SMART Control is focused on, as opposed to all these other factors, device resets, etc. Yes, sir?
So what I was sort of thinking of was, what about device age? So sometimes you will have an old disk that nothing bad has happened to it, so it's never actually throws anything, but at the same time, you might want to know that that disk has been around the block a little longer than you're comfortable with.
So device age, I touched on the CDR and CUDA. You can get them in the US at Costco, where there's a pallet of them, and they're about as affordable as disks get. And I see lots of them in the field, and at 3 years, one should generally start thinking about replacement. Do you have direct experience with other models or otherwise that?
Not anything else, but I was just thinking that I know a smartphone, that's not something I get out of it.
Do you have the data, or you never thought to?
I think I
factor
have the
that in?
data, actually.
I mean, if you get this big old number of thousands of hours, it's easy to just think, oh, that doesn't mean anything to me. But if you start graphing that, oh my,
I actually have it.
It's crawling and then it drops. Okay, well,
I was just Effectively, it's just something that I've occasionally sort of worried about, that like, oh, do I know how old any of these things are?
So, are you simply using the smart control utility? Are you doing anything automated?
No, nothing automated.
Would you like something
in any way,
automated?
shape, or form?
Yeah, so there is the SMART D utility, which is taking just, I believe, just catastrophic pass or fail into consideration. As Rod pointed out, there's no going back on a SMART failure. When SMART decides a device is done, it's done. Now, to only be notified of that is a pretty darn binary, primitive, blunt instrument on diagnoses. So, hours and temperature and reset counts beyond, and I'll say then, of course, the reallocated sector counts, are containing a lot of wisdom that isn't always obvious, and if you're dealing with those 90 drives in one single system, you don't want to be manually saying, oh, let's go compare my notes of how many hours and all that. And I've found that, okay, they've been messing around with their array. All these disks look identical. Maybe they were really careful and got them all in the same series. Some of them have been in production for 2 years, some are the spares. They all look alike, and I don't know, just standing there, which are those spares. So simply making it easy to query them and then make decisions based on them. For example, ZFSD, the disk replacement daemon, is hopefully very soon going from a FreeBSD project branch to head. And if ZFSD is making a decision to replace a disk and it has 2 spares, should it make that decision on those number of hours and use the younger disk first, given a choice of 2? And a human being would maybe think that's a no-brainer. Well, yeah, here's the fresh one, and it's a pretty important array. And similarly, Automagic scares the pants off of me because I know the future of that machine to some degree. It could be that we need this one half a terabyte of data, we have 2 spares. The absolute best thing I can do is make a mirror of those, copy out that 1 bit out of many terabytes, because I know it's getting wiped. The rest is logs, don't worry about it. And the system itself is like, oh, well, your disk has failed. You obviously care about all of it. No, I might not. So, that's where a library could be useful, and that's ZFSD is saying, making those decisions. Choice of 2 or 3 spares, start with this one based on this criteria. Or the current temperature, or obviously if one's super obviously, if one of the spares has issues, you don't want to use it. But it simply says there's a spare, let's use it. Because that's what we're told to do. Other experiences in the field. Netflix? Anything from Netflix?
Oh, sorry, I was coming down. Oh, the question?
Oh, the question is just experience in the field. Non-intuitive evidence from storage arrays, because the disk might not be guilty of anything, but it may fail because of external factors. And we all collectively will benefit from identifying those factors and then quantifying them.
The biggest things that we've observed, and we have tens of thousands of disks in the field, is that it comes down to the manufacturing quality of the disk, and a lot of times it's related to the part of the disk, the manufacturing run, or model number. We've seen 3 things. Our first set of disks that we deployed came from Seagate. I'll say I don't want to point the finger at any one vendor. They came from Seagate right after the Thailand flood in 2011, 12, whenever it was. Seagate was the only company that was willing to sell us this at the time because everyone was short on units, and unfortunately, all those drives failed within a year or 2. I shouldn't say all, but enough failed that we wanted to replace them all. That doesn't mean that Seagate is a bad company. It's just that it was tough times for everyone. They were scrambling to get product out. Ever since we moved off of Seagate, we've been on Hitachi healing drives. Those have been fantastic. Those have been failure rates that have been super duper low. I think part of it's due to the fact that healing is just the ideal material for making hard drive inners out of. But it's been super good. We haven't seen anything that's put us to there being a trend in failures. So that came down to we chose a good drive with good manufacturing characteristics. And then on SSDs, once again, that comes down to how much money you're willing to pay for it. If it's 1 write per day, if it's less than 1 write per day, if it's 10 writes per day, what your workload is. So, Backblaze just released a paper a month or 2 ago on updated their observations on disk drives. They actually run at a much higher scale than we do. I was just looking at it. It's very informative on different vendors and, like I said, much bigger sample set than we have. I'd say we've been lucky as long as we've stuck with a proven reliable vendor.
So for the live stream, helium drives have proven very reliable. And I'm curious, I remember the floods, and at Costco, you could look at the pallet, and there is Thailand and China. And you would watch them draw down on Thailand and increase on China. I'm curious if one of the, perhaps a new factory, did you notice what country of origin they were? Because maybe the new factory wasn't quite up to snuff yet.
Well, right after the floods, all our load was Thailand. The diversification in China didn't happen until after the floods because of the floods.
Because of the floods, okay. Interesting. And then how can you academically attribute failure of a model to the floods themselves, it seems, from existing factories?
It's because it wiped out production, so but didn't wipe out demand. And what happens then is that drives that don't quite meet the normal QA wind up being put into a box anyway.
When in doubt, lower your standards. I see. Interesting. I don't want to beat up on any vendors, but these are practical issues that we all face. Does anyone have 2.5-inch statistics that might be relevant and interesting? That same large big box vendor has 4 terabyte, pretty full height, 2.5-inch drives, but that's a pretty impressive device. But once you start committing 4 terabytes to a tiny little device, is that a brilliant thing to do or not so brilliant thing to do? I'm curious if anyone has insights there. Yes, sir.
On the side of the Backblaze report, I know Google has released a few weeks ago a statistical report on millions of mostly SSD drives. And the very interesting takeaway was that the flatter plastic style hard drives will fail over time, so you actually have that 8-hour window or some kind of head start if you monitor this correctly. And compared to SSD, an SSD, if it's actually a quality drive with a lot of spare space to be able to do bad memory cells, it may not fail. You may not know it, but it's going to corrupt it. You're just not going to know it. By the time you notice, your files are going to be corrupted. So like what ZFS does, check something is very, very important.
This article is very nice. The basic conclusion is like because they try to predict when the disk will fail, they got the same. And they cannot. They realize that all that they try to do as much as they can, collecting data, they still cannot predict when a hard drive will fail.
Okay, for the live stream. Out of the Google report, looking at SSDs, and I thought you were going to mention just the abrupt death or the 32K MacBook drive, where that was pretty hot stuff about 2 years ago. They are finding that the indicator of trouble is corruption, data corruption, which is mildly terrifying. I've heard of flash devices, say, failing catastrophically if power is lost during a write. Have you encountered that play in? But that's a rather terrifying notion that data corruption can be the result, and naturally file systems like ZFS are taking precautions, and very few file systems are taking those precautions. And as we move to SSDs and all want them, want in really big quotation marks, that is most enlightening. And then, do you see there being metrics beyond a ZFS scrub that should be, precautions that should be taken, or is that about the best we can do, is just check someone's there and hope for the best? Any thoughts? Okay, so very, very good point. Any other terrifying real-world experiences by small and large users? For the wish list, any just wish we had this thing? Any scripting languages to focus on beyond Python? Because that sure come up, and I sure want to see just shell, because when you're doing support, you have to assume nearly everything's broken. You've got VI and shell at your disposal, and that's typically it. So that's where I operate. But all of you, I hear Ruby's big in Japan. Other
You
needs,
should
wants?
probably not care about scripting languages, because if you provide the library, people will make the bindings.
Okay. Focus on the library, provide the bindings, and they'll come up with the clever things there.
Yeah, and if it's shell-like, I'll be doing it in Perl anyway, so.
Excellent. The Perl folks.
For the issues to include these in the sheet that is in the base system, must be some language that we have in the base system.
Sure. Or at least the interfaces among other choices, so you have a starting point.
Yeah.
Sure, sure, sure. No other wish list items? I'm sure you.
Just make sure that your output is parsable with awk when you're done.
EWK awk?
Yeah,
Okay.
that's why if you do check in shell, you will use awk anyway to get the output and do things.
Sure.
And so make sure it's parsable, not like ZFS.
So, in my hometown, some colleagues have home alarm system interfaces to computers and networks. In all practicality, do you see your storage arrays blinking lights, notifying you on your smartphone, blasting a really loud siren, or otherwise? Or does physical security play into these same factors? Should that be treated with equal weight to, you know, at one point was just this one focus on smart data and nothing else. No environmental variables, no human factors, no nothing. Any insights there?
So my storage that I have at home, when I have some problems with disk, I have a siren that will be quite scary. The first time that I saw.
And is that something, okay, you have a siren that triggers from your own home
No,
NAS?
no, actually it's inside the NAS.
Oh, really?
It's shielded with this small bit buzzer.
A buzzer. What model NAS, if I may?
No.
Okay, a few NAS that buzzes at you.
By the
That's-
way, I consider it to be completely worthless.
What's that?
I consider that to be completely worthless.
Worthless for you personally? Okay.
Sure, but yes, it's worthless.
Interesting. Okay.
Well, if it's a home, it is.
Yeah, except when you're not home, then who hears it?
Yeah.
Right, like not home, you don't hear the buzz. Well, what if it beeps your smartphone? Because a lot of these alarm systems provided by your cable modem provider and internet provider happen to be all integrated. I won't even comment on the Internet of Things aspect of it, but
Well, an oral alarm on any kind of computer when it's useless.
okay, so oral alarms specifically, but having that data.
Oh, yes, absolutely.
Okay, so
That
that
actually makes it a lot worse than useless, because useless makes it sound like it might be harmless.
Right.
You've actually moved into, you know.
Considered harmful.
Considered
making me wanna
harmful,
throw
okay,
hardware out
oral
the window.
alarms. Anyhow, I know some storage vendors have blinking lights and various indicators. One idea on the physical security is that if it's an encrypted volume and you know there's physical compromise approaching it, do you dump your keys? Take some precaution that plays in with the encryption of it. How paranoid are you, etc., etc. So, any and all insights there are appreciated. Anyone on the cloud, surrendering their storage to a vendor you'll never meet in person? Anyone? And what do you feel you deserve as for information provided by that vendor that you're paying on a monthly basis and putting the coins into the slot? I saw a hand in front here. Any thoughts there?
I don't pay enough to deserve much.
Cloud does mean a race to the bottom on price and perhaps quality, and if you're not paying much, no, maybe you shouldn't deserve much. Fair enough, but
It would be nice to have latency less than like 100 milliseconds most of the time.
performance is a concern more so than will it be there tomorrow morning at 9 a.m.
I don't think anything there gets important.
Okay, nothing important. I'm sure other people have something important out on the cloud. How are we on time? Okay. Please do contact me in the hallway or otherwise electronically. Thank you so much, and the rest of your conference.